Let's apply Stokes' theorem to evaluate the integral over closed curve f dot dr, where f is given to be xyi plus xy squared j, and closed curve is the square with the vertices 0, 0, 0, 1, 1, 1, 1, 0. So we want to apply Stokes' theorem to evaluate this integral. Let's draw the closed curve, and so we have a closed curve. Obviously, if we want to calculate the integral along that closed curve, we should take an anti-clockwise direction. Let's start from 0, 0, then go up to 1, 1, 1, whatever, etc., etc. Then we can see that if we want to evaluate the integral along this closed curve, then we have to evaluate along this line, then also evaluate along this line. You have to evaluate this line along this line and also this line. So you have to evaluate the line integral 4 times. That will be quite tedious, though we can do it. It will take lots of time. But let's recall the statement for Stokes' theorem that says integral over closed curve f dot dr. That's what we can, if we want to do that, we have to do it 4 times along the square, 4 of the sides of the square. However, we also have that integral over closed curve f dot dr equal to surface integral of curl of f dot n ds. So Stokes' theorem basically converts the line integral to a surface integral. So let's try to evaluate the right hand side curl of f dot n ds, surface integral of curl of f dot n ds. For that, of course, we should compute curl of f, and we are given f equal to, what is f? xyi plus xy squared j. We are given f equal to xyi plus xy squared j. And how do we find curl? We just compute the something called determinant I j k del del x del del y del del x del del y and then del del z of f. Where is f? F is xyi plus xy squared j. xyi xy squared j. What about z component? Of course, we have xy squared j. We can simply write it plus 0k. So z component is 0. Z component of the field is 0. Now we can compute this to be del del y of 0 is 0, del del z of xz square is also 0. So I component is just 0, so we can write it as 0i. J component, del del x of 0 is 0, del del z of xy is also 0. So j component is also 0. What about k component? Del del x of xy square, that survives. Del del x, the partial differentiation of xy square with respect to x is y square only. You are treating y square as a constant if you are differentiating partially with respect to x. And then del del y of xy is just x. So okay, let's write it out. Del del x of xy square minus del del y of xy times k equal to y square minus x times k. Next, we have computed the curl of f, but is that enough? No. We need normal, outward normal. You need normal. If you have this to be x-axis, then y-axis. Obviously, unit normal to xy plane is the unit vector k. So n equal to unit vector k. So let's compute integral over surface integral of the right hand side of Stokes theorem. Surface integral of curl of f dot n ds. Curl of f, we have just computed it to be equal to y square minus xk. So that is equal to surface integral of y square minus x times k. Unit normal, as we have observed, normal to the xy plane is z-axis, and we have here that's equal to k. K dot k equal to 1. So integral, we just have in surface integral of y square minus x ds. Now we want to evaluate the surface integral along the square. This region, we want to just evaluate the surface integral along this region. You observe that x will change from x equal to 0 to x equal to 1, and also y will change from y equal to 0 to y equal to 1. Once again, x will change from x equal to 0 to x equal to 1. Y will change from y equal to 0 to y equal to 1. Pretty simple. That's the, I think, simplest surface that we have. Let's do it. So this surface integral is nothing but integral x is changing from x equal to 0 to 1 dx, and then y is changing from y equal to 0 to 1 y square minus x dy. Now we want to integrate with respect to y first, so let's keep x equal changing from 0 to 1 as it is. Integral of y square dy. Integral of y square dy is y cube by 3. Y cube by 3 minus integral of x with respect to y is y only. Your y is changing from 0 to 1. X, we are leaving it as it is, because if you are integrating with respect to y, we will treat x as a constant. And once again, integral of y square is y cube by 3. Integral of x, that is treated as constant with respect to y, is xy. Now we are changing y from 0 to 1, so this is equal to x as it is. Integral x is changing from 0 to 1, and y upper limit, if we write upper limit y equal to 1, then we have 1 by 3 minus x into 1. Lower limit, if you write it, we get 0. Now we need to integrate with respect to x everything. Integral of 1 by third with respect to x is 1 by third of x. Integral of x with respect to x is x squared by 2. That we need to integrate from 0 to 1, and if we do it, we have 1 by 3 minus 1 by 2, and that is equal to minus 1 by 3, and we are done.